Great. Okay, let's start it. Okay. All right. So we didn't finish the sampling from the previous session. So I'm going to continue with that. And then we're going to move on. I'm going to then just explain the assignments, assignment 2 and assignment 3, and then we're going to move on to validity and reliability. Sorry, can you just let me know if you can hear me all right? Am I
we can hear
audible?
fine.
Yeah.
We can hear
Okay,
fine.
good. Okay, thanks. So we'd gone through the different types of sampling, and I want to talk about, if I can move the slide on, sample size and variation. Stop it. Okay, sorry, I've got a cat on my desk that's chewing some files. Let me just get it out. Come on. Off. So sample size is very important for quantitative research, and it's also relevant for qualitative research as well. And it links into variability and the ability to generalize your results to a larger population. So when you're doing quantitative research, it's recommended that your sort of minimum sample size would be around 20 cases, but that's also, it depends on what you're doing and what kind of population you're targeting. And the reason why we try and avoid small samples is because they're likely to have a high level of bias in them. And remember, we spoke about some of the biases that come into the process of sampling. So, for example, just as an example here, sorry, if you if you're sampling recyclers from central Johannesburg, and you end up with a sample which is young men and they're recycling glass, that sample is not going to represent the population of recyclers because there's both male and female recyclers and they recycle many different kinds of products. So that's why we need to be careful when we use small samples, and they're not useful for quantitative analysis. This figure demonstrates the relationship between sample size and sample variation. So you can see the bigger your sample becomes, the less error you're going to have in the measurement of that you are, or the characteristics of the sample that you're measuring, because the more cases you have, the more likely those cases are to represent the population that you're trying to represent. And you'll notice that as you get to larger sample sizes, the error doesn't get any worse. So, and you'll see with the sample size table that I'll show you in a minute, that as you get to a bigger population, you don't need such a large sample to represent that population because the big sample is representative. Okay, we can estimate required sample sizes, and this is an example of a formula that we can use. There's different formulas we can use depending on what kind of statistics we're doing. This is a very simple formula, but in order to use the formula, you need to measure something. So you'd need to conduct a pilot study for your study and measure your dependent variable. So you need to get some kind of measurement of your dependent variable, and then we can use the information from that measurement to estimate the sample size. So N is our required sample size. S is the standard deviation of the measure that we've taken in the pilot sample. So let's say, for example, we measure self-esteem among students. We would conduct a pilot study, and we'd use an instrument that measures self-esteem, and then we would get a mean and a standard deviation for that measure for the group of students that we're targeting in our pilot. So this S is the standard error from that measurement that we've taken. So you have to do some field work in order to get that result. D is the tolerable margin of error at a specified measure of level of confidence. So that's a value that we set depending on how much error we're prepared to tolerate for our study. And then Z is taken from a Z table corresponding to that level of confidence that we're working with. So we get Z tables which give us a Z statistic. So that's most of the information comes from either part of the information comes from something we've measured, part of the information comes from something we decide, and part of the information comes from a statistical table. Okay, so if we, using an example, we've got a pilot sample that we've collected information for, and we get a standard deviation of 10. Then we decide that the margin of error that we can tolerate is 2.5 at the 95% level. So that's something we decide. We normally work in social sciences, we normally work at 95% confidence levels. In medical situations, we would work at a stricter level than that. So we might say 99 or 99.9%. Depending on what it depends on what the research is focusing on. If you're testing drugs, for example, you want to be very confident that your result is correct. So you'd work at a much stricter level of error for that kind of research. So taking that information into account, we would end up with 2 times 10. 2 is 2 would come from the Z table. 10 is the standard error. 2.5 is our tolerable amount of margin of error. And then we square that. The 2 should be superscript, but it's squared. So that means and that would give us a required sample size of 64. So if our pilot sample contained 30 observations, that would mean we need to get an additional 34 to reach the sample size that we need for the given amount of error that we're prepared to tolerate. So what should be evidence from this is that the higher your standard deviation, the bigger your sample size is going to need to be. So because then you need to control for that variation. So this is just to demonstrate that we can estimate required sample sizes, but you do need some data in order to be able to do that. And then there's different formulas for different statistical tests. So there's a book called Medical Statistics by Stern, and that book has different formulas for different kinds of tests depending on what test you're using for your analysis. Okay, if previous research has been published, you can use the same measurements if previous research has been published, and if you're using the same measurements that other researchers have used, it might be possible to use their results to estimate a required sample size for your project. So we call this kind of a priori estimation. So you're using somebody else's results to try and estimate what your sample size would be, should be. But it's not always good to do that, because if the context is very different to your context that you're working in, it might not be a sensible thing to do. There's also lots of online resources to estimate required sample size. So this is a website which is called Rayosoft, and then they have a sample size estimator that you can, they have a formula that you can use to estimate required sample size for your study. So you put in the information, maybe what your population size is, what amount of error you're prepared to accept, and so on. And then it will, much like that formula that I've just shown you, and then it'll give you a estimate of what sample size you need for your study. Just to make a note about this, I mean, in the ideal world, if we're doing a project, you obviously have a desired sample size, but in practical terms, it might not be possible to achieve that sample size, and that doesn't mean that the research is less valuable or shouldn't be done. So if you've got a student who's doing a research project, and in their proposal they say that they're going to get a sample size of 500, and then they only get 200, they should still carry on with the research and finish it, and then just acknowledge that there's a limitation with the sample size, as long as they can do the analysis that they need to do with a smaller sample. And there are techniques that we can use, statistical techniques that we can use for small sample sizes. So there's always sort of usually a way around the problem. So just because the student doesn't achieve their sample size doesn't mean that the study shouldn't be usable, for example. Okay, so that's and they'll still get some interesting information. It might not end up in a high-end journal, but it'll still have some value to the conversation that's going on that particular topic. Okay, this is a table that I use, I share with researchers, students, and supervisors, which it's from a group called the Research Advisors. And what they have a table where it shows you the population size. That's in the left-hand column. And then there's two levels of confidence. There's 95% confidence and 99% confidence. And then there's a margin of error percentage there. So if you, as I mentioned earlier, in social research, we normally work at 95% confidence. In medical research or in scientific research, you're more likely to work at 99 or even 99.9, which is even a stricter level of confidence. And then the margin of error is obviously if you're prepared to, normally we might work at 5%. But if you want a stricter margin of error, you would work at 1%, for example. So we in social sciences, we normally would work at 95% and 5%. So what this table tells you that if your population size is 100 on the left-hand side, if you working at a 95% confidence level, you would need to achieve a sample size of 80. If you want to work at a 1% level, you need to achieve a sample size of 99. In other words, you virtually need to sample the entire population. And then if you're working at a 99% confidence level, your sample sizes would be larger, 87, 93, 96, and 99. Not much larger, but you'd need a better representation if you want to argue that your sample has got a stronger level of confidence. So this is a table that you can also use for working out based on the population size, what kind of sample size you would need. Now, the issue with this though is that this is all very well. You can use this if you know what the population size is. If you don't know what the population size is, then you can't do these estimates because you don't have a population size to work with. And that's why quite often we have a project where we have to work with a non-probability method because we don't know what the population size is. We can't really do an estimate. Often people will know, or the researcher might know what the population size is, but there's also going to be instances where it's very unclear what the population size is. And then you might have to do a guesstimate. You might have to make an estimate of the population size, and then justify that, and then work on the and then go for the and then do an estimate based on that sort of estimate of the population size. But as soon as you start estimating, there's going to be doubt about how accurate the number is. And then that's going to, that gives people or reviewers and examiners a way in to say, how do you know what the population size was? How accurate is your estimate? So that can make life a bit difficult. So this is the top end of this is the bottom end of the table. And what I wanted to demonstrate, so this is the same table, but it's just showing the last set of rows in this table. So on the left-hand side, we have population size, and then we have sample size, required sample size based on different margins of error. And the reason for showing this is to demonstrate the point that first of all, your required sample size doesn't change if you've got a huge population. So if you've got a population of 1 million, the recommended sample size is 384 from that million. And if you've got a population of 300 million, the recommended sample size is still 384 at the level of 95% confidence and a 5% margin of error. And then obviously your sample gets bigger the required sample size gets bigger if your margin of error is lower. So you go from 384 to 9,512 if you're going from a 5% error to a 1% error. But it doesn't really, that number doesn't really change much if the population increases. Because 9,500 is a large, very large sample size, and it would be considered a good representation of a million people, or a million households, or a million documents. So, if you look at these numbers, when Stats South Africa, for example, do their household surveys, they do a labor force survey every 3 months or every 6 months, and they do general household surveys. I'm not sure how often they're doing them these days, but they used to do them once a year or every 6 months. When they do those surveys, they don't sample millions of people or millions of households. Their sample size is normally about 30,000 households to represent the South African population. So, and the reason why they don't need such massive samples is because that smaller sample can be considered representation as long as the sampling method is good. That 30,000 should give a good representation of the 60 million people in South Africa. And then so there's the HSRC, the Human Sciences Research Council. When they do their surveys, they sometimes might have a sample of 2,000, for example, to represent South Africa. So you don't need huge samples to represent a very large population. So it's an important. So as the population gets bigger, your required sample size relative to that population becomes actually smaller, because big samples are representative of large populations. All right. So some statistical procedures require specific sample sizes. So if we're doing a factor analysis, an exploratory factor analysis, the recommended sample size is 10 people per question. So if you've got a questionnaire measuring self-esteem and you've got 10 questions measuring self-esteem, then that would mean you'd need at least, 100 participants to analyze that measurement scale of self-esteem. So we do work with smaller sample sizes, so 5 respondents per question, but that can sometimes give sort of unstable results. So the bigger the sample size there, the better. For structural equation modeling, which is a sort of complex, it's a complex way of modeling data. We work with sample sizes of 250 to 500 participants or cases. Although we can, with newer software and newer mathematical models, we can work with smaller sample sizes. So it's depending on what statistical procedures we're using for the structural equation modeling, we can use smaller sample sizes. If you're comparing groups, our recommendation would be a minimum of 20 per group, but that's it also depends on what you measure, what you're comparing for the groups. So whatever measurement you are using, that would be we would normally say if researchers, if students want to compare groups, we would say at least a minimum of 20 per group. And then if the student is doing descriptive analysis, we would say minimum sample size 20 to 30. Sometimes students from the health sciences would be doing research testing a procedure, so they might be doing an experimental design where they have a group of patients receiving a particular treatment and then another group of patients receiving a different kind of treatment to compare whether one treatment is more effective than another. And in those cases, because of the logistics of organizing patients and the time it takes to treat the patients and so on, they might work with smaller samples. So they might have 15 patients in each group, sometimes even 10 patients in each group. You can do that kind of research, but it's very difficult to get meaningful statistical results because if the differences in the groups are small, it'll be difficult to identify the or to achieve statistically significant results. So that's yeah, the recommendation for quantitative research is always the bigger the better. The bigger the sample, the better. Okay, and that's yeah, right. Then yeah, just to note that again, going back to the linking the sampling to the parametric test. I think I mentioned this already. One of the assumptions of parametric tests is that the measurement was obtained by using a random sample from a population. So that's an assumption that's made by, it's an assumption that we're supposed to adhere to for parametric tests, but it's quite difficult, as I mentioned earlier, to achieve a random sample often. Because we don't know what the sample, we don't know what the population is, or it's difficult to achieve a random sample in practice. It looks easy on paper, but when you try and achieve it in the real world, it might be more difficult to achieve it in the real world. Okay. Then this is coming back to the Henry chapter, the questions that Henry asked. These are post-sampling questions. So one question is, how can non-response be evaluated? Is weighting necessary? And what are the standard errors and related confidence intervals for the study estimates? So starting with the last one, that's kind of asking the question, what kind of variability is there in the measurement that we've obtained? Is there are the confidence intervals wide? Is the standard error high? If the standard error is high and the confidence intervals are wide, it means that there's a lot of variability in the measurement, and that could potentially be a problem for. So if you're trying to compare groups for a measurement and you've got high standard error and wide confidence intervals, it's going to be more difficult to identify differences between groups. And it also means that the measurement, it means that the sample might not be, it means that the sample's got a lot of variability in terms of the measure, and that's so it might mean that you need to get a larger sample, for example, to reduce that variability. Is weighting necessary? I mentioned this earlier, but weighting refers to applying a formula or applying a calculation to the cases to either increase or decrease groups so that they're more representative of a population. So they're sometimes I've seen, yeah. So weighting is used in the national surveys. So if the organization that's doing the survey has oversampled a group or undersampled a group, they will use weighting to multiply the cases so that the distribution of cases is more similar to what, or similar, so that the cases then represent the population. So if you've undersampled informal areas, for example, you can then if you've undersampled informal areas, you can then apply a weighting factor to the cases of the informal areas so that they're multiplied. You might multiply each one by 2, for example, to increase the number of those cases. We can also weight data so that it represents the population. So if an organization does a survey, and you want that survey to then be represent population numbers, you can multiply the weighting factors to get a population figure. Yeah, and then we don't often use weighting in sort of standard research. It's normally used in population-based research, or so big national surveys, for example, might use weighting. We don't often use weighting for the projects that we work on, and the only projects that I've ever used weighting on have been stats essay surveys where they've applied a weighting factor. I've not ever weighted a sort of study myself. Okay, and then how can non-response be evaluated? Non-response could refer to two dimensions. It could be participants that don't respond. So you might have targeted a group of people, and then some of those people don't respond. So for example, with online surveys, the sort of research suggests that it's certain groups of people will reply to online surveys. Not everybody will. And that means that you might have a biased sample in terms of who's responding. So you have to then decide what are you going to, if you identify that there's groups of people that haven't responded to a survey, or haven't participated in a group of patients that haven't participated in your research. What is the implication in terms of the representation of that sample? How do you need to go and sample more people of that particular group, or do you acknowledge it as a limitation? How do you deal with that? And then the second type of non-response is non-response to a question. So you've got people answering the questionnaire, but or giving you information in different contexts, but that there's certain information missing. So it might be a particular question where people don't answer that question because it's not relevant to them, or they don't understand it, or something like that. So in that case, you have to then make a decision about if you get a high non-response rate, that means that you have to reconsider the value of that question, or that measurement that you're taking, because it might be a problem. But yeah, so there's different. Obviously, you don't want to get high levels of non-responses. Yeah. All right. If you know the characteristics of the population, you can use statistical tests to establish if your sample characteristics match with the population. So, for example, if you know that a population has 40% men and 60% women, and you obtain a sample when you sample, you're going to have the distribution of men and women in your sample. You can test your observed percentage against an expected distribution using a one sample chi-squared test. And if you do that, that then allows you to say, my sample is I've got the same distribution in my sample as you have in the population, and that sort of gives you a sort of stronger argument to be able to say my sample is representative of the population. So, Corin, you've got a question?
Yeah, sorry, it was actually on the previous slide about missing.
Yeah.
Sometimes when you do an online survey, you can't actually move forward unless you answer all the questions. Do you think that's a better or worse way of doing it? Because somebody might end up leaving the survey altogether, as opposed to just missing that question. What would you recommend as a better way of conducting like those particular? And I suppose if they can't answer a question, or they won't, that's some kind of information in itself.
Yeah. So ethically, yeah, it's a big problem when researchers force participants to answer questions, because ethically, if you look at the ethics guidelines, any person who's participating in research has the right to refuse to answer any question. So when people set up these online surveys, when researchers set up these online surveys and force the participants to answer, that's actually unethical research practice. So what we do when we host online surveys, sometimes you have to set a question as compulsory because it's so, for example, the consent question at the beginning of the questionnaire would be compulsory, because if they say no, you want to get them away from the link. So what we do is we set up the survey. That first consent question will be compulsory. If they say they consent, then they'll be directed to the beginning of the questionnaire. If they say no, then we direct them to a thank you page saying, you don't, we direct them away. And then there might be other questions where you need to set it as compulsory because it's branching. And if they don't answer that question, then they could go anywhere in the questionnaire. So sometimes those questions can be compulsory. But all the other questions should be optional, essentially. So what happens, excuse me. So what happens usually, depending on how interested the person is in the survey, what usually with online surveys, so what we do is for all the other questions, the program that we use has an option where you can, there's 3 validation options. There's no control over the question. There's a remind the person to answer, and then there's a force the person to answer. So we very rarely use that force the person to answer because it's not ethically appropriate. Because as I said, the ethics guidelines is that the participant has a right to refuse any question that you ask them. So then we use the second option, which is remind the person that they haven't answered it. So if they skip a question, they'll get a little note saying you haven't answered this question, but they're still not forced to answer it. They can leave it if they want to. So that's what we do. And I think we use the program called Question Pro. But I'm sure with most of the other online survey options, there should be and I know with Google Forms, there is an option where you can take off the force the person to answer the question. I think it's set with that on. So I think the default is that it forces the person to answer, but the person who's developing the questionnaire can remove it. And then you just have to take your chances with who's going to answer and who's going to complete the questionnaire. But that's the correct process. So usually what happens is with online surveys is you'll get a sort of a fall off. So lots of people start, and then by the section B, some people will drop out, and then by section C, even more people will drop out. But there will be those that complete the survey. So I think if you're having problems with people, so I won't complete a survey if I'm forced to do it. So just on principle, just irritates me. So if I get a questionnaire where I'm forced to answer the questions, I won't actually answer that questionnaire. They did it UJ many years ago now. They gave us they were doing a culture survey, and they'd done exactly what you're saying, is where you were forced to answer all the questions. So gets to a question, and I always use this example: does your boss look after his health or her health? Well, I don't know. Do they go to gym or something? That was the question. And I think I don't know, but there was no don't know option, so I couldn't agree or disagree with it. So I just said, no, I'm not answering this questionnaire anymore.
Leave the whole thing.
Yeah, so I would say the recommendation I would make is if there's an option with the program to remind the person, but don't force them to answer the questions. Yeah, and then so what will happen is some questions they won't. My experience with online surveys is if the person is going to answer, most people will go through to the end. Some people might not, but but that's the way it is. They just, The other thing is you can also do a save and continue with our program, where you can do a save and continue option. So if it's a very long questionnaire, then they can leave the questionnaire and then they can come back. But I think often what happens in those cases is the person probably doesn't come back again. So the trick is to ask shorter questionnaires, which are of interest to the person, and then they probably will complete it. So in your experience, what are the problems there?
So I think exactly what you say is you get to a question that you don't know or you don't want to answer. Instead of just being able to skip past it, people end up leaving completely. So I think it would be exactly that. So I actually don't know why people don't allow the option to skip questions. Yeah.
I think there's a misunderstanding in the sort of in some environments that it's okay to force people to answer the questions, and it's not seen as being forced. It's just I want to get answers to all my questions, and I'm going to do it this way. But I also think something like Google Forms, I think the default there is, I don't use it, but we have got students that use it. And I think the default is that it forces the person to answer the question. So if you're designing the questionnaire, you have to remember to take it off. And if you don't, if you're doing something quickly and not thinking about that, then you'll leave it on the default, which is that it forces the person to answer the question. I also think people they're not confident enough to, they worry about not having information. So they force rather than rather than sort of worry about having to deal with how do you deal with these non-responses later on. So yeah, but I think if you follow the ethics guidelines, the ethics guidelines are very clear that you can't force people to answer questions. So by setting the questions as compulsory, you're actually forcing the person, and that's ethically not okay. Yeah. So that's so I think if somebody's designing those kinds of questionnaires, I would raise that with them and say, you need to find a way of not forcing and giving the person the option, and then you'll get a more accurate answer anyway. Yeah, you get more people answering, as long as the questionnaires are not too long.
Yeah. Thank you.
I've just designed, well, I'm working on a very interesting project where the researchers are looking at safeguarding in sport. And they've got these very long questionnaires I can just see the people when they answer them, it's a very interesting topic, and the questions are very meaningful, and it's very important work. But I can just see the participants when they try and answer these questions that they're going to get halfway through the questionnaire and just think, I can't carry on with this unless they're really dedicated to the topic and that. And that's going to be interesting to see how the researchers, how many responses they get. Hopefully it will be a good response because it's a very good study. But you run the risk with long questionnaires of alienating people. So when Stats South Africa and these big survey organizations do studies, they have, I think, I'm not sure if they're still doing it, but they have field workers. They have these very long questionnaires. They're 30, 40 pages long. And what they do is they go out into the field. They have a field worker who sits with the person. And I think that's the best way of doing those longer questionnaires, is to have somebody actually administer them rather than sort of trying to do them online. Yeah. We'll talk about online surveys a bit more because we're getting, since COVID, we've had a big increase in online surveys. And often they work quite well, and sometimes they don't work very well, depending on the topic and the target audience. The sample, the target sample. Yeah, but I think I'm always suspicious when a survey comes in and there's no missing data. It's probably a case where they forced the people to answer, but that's not. The ethics is participants have a right to refuse questions that you ask them. So if it's compulsory, then they're not there. You're taking away that right, which is not good. Yeah.
Yeah.
Okay.
Thank you.
Yeah. Okay. So if you achieve a large sample, so this, going back to this issue of it's not random sampling, going back to this issue of normal distribution, which is a assumption of parametric tests. If you obtain a very large sample, there's something called the central limit theorem, which is if you have a very big sample, let's say 100 cases or 200 cases, if you take small samples from that large sample, those small samples will have a normal distribution, and that's a phenomenon that's there's a nice exercise in one of the books that I have. I think it's from the medical statistics book, where they have this nice exercise where they demonstrate that effect. So you can, if you've got a big sample, you can invoke the central limit theorem and sort of argue that you do have a normally distributed sample, even if the variable itself isn't normally distributed. If you took subsamples of that variable, then it would have a normal distribution. So that's so that it's kind of making the point that the bigger your sample, the more likely it is to be. Yeah, you can sort of invoke this normal distribution case. Okay, and then just if a student has problems with their sample, it's important to acknowledge limitations, and there might be things that they can do to address the limitations, but it's just important to, let's say, for example, the student said in their proposal they want to get a sample size of 500, and then they end up only getting 200. As long as they explain why that happened and they've got good justification, then I think it should be reasonable and accepted. Okay, we have had cases where supervisors have kind of forced students to go out and get more cases, but I think that's also a bit unfair on the side of the supervisor, where it's almost bullying the student because the supervisor might be interested in publishing some research based on the student's work, and then they force the student to go out and get more data, even though it's quite difficult for them to do that. So one needs to avoid those kinds of behaviors. If you have a bias sample, you might be able to use weighting or reweighting to adjust the distribution, or you could just say that the sample is biased and not worry about weighting. And then if you have a small sample, there's a process called bootstrapping, which basically replicates samples. So that's a process we can use if we've got small samples. The other option with small samples is there are techniques that we can use for analyzing small samples as well. So it might mean that your analysis plan changes, but there's usually a way of dealing with it. The other thing to say is that so I have sometimes supervisors ask students to do quantitative projects because for different reasons. It might be that the discipline is more quantitative, or it might be that the supervisor has a quantitative orientation, or they want the student to get experience doing quantitative research. But when the project goes wrong and the student can't get a sample, which does happen, then you need to have it's almost like you need to have a plan B, which would then be to pivot to a qualitative kind of design if possible. And that's where mixed methods works quite well, because if you're doing a mixed methods study, you would then have a qualitative component anyway, and then you can sort of just show that the quantitative didn't work out, and then you focus on the qualitative. So you might have to adjust your kind of framing of the qualitative of the mixed methods design, but you still have something to work with. Where it goes horribly wrong is when the student can't get a sample. And it does happen. We've seen cases where a student might have arranged with a company to do their research with the company, and then suddenly things change and they can't get access to that company, and then they're 3 months before their project is due, they're scrambling around. We actually had a case. I had a case yesterday where there's a master's student who needs to finish her work by the 15th of October, and she hasn't collected data yet. So there's a lot of scrambling going on in the background. So don't, so that shouldn't be happening.
Doc?
Yes, Teboho, yeah.
Sorry, I just wanted to ask, so in this case, this type of study, how do you now go about handling missing values? Let's say from your questionnaire, after you collected data, you find that the missing values, some of the columns have a lot of missing values. Because I know in my case, the type of research I do, we do have techniques that help to handle missing values in your raw data. If you have raw data or image data, or whatever type of data that you might use, or video, we do have techniques that we use to handle the missingness within the data set. Or if the missing values are a lot, some of them will drop them.
Okay.
Yeah.
So it's an interesting question, and I'll talk more about it when we get to the data analysis component, because that's kind of where. But I think it's relevant to talk about it here as well. So there's different procedures we can use to deal with missing data. I actually have a colleague who is doing a PhD. Who's had a kind of disagreement with a supervisor about how to handle missing values. So my philosophy about it is that if you have records, and it could be somebody answering a questionnaire, it could be records from a procedure that you analyzing, so it might be, based thinking about the work that you do, information systems, it might be some data from a process that you're following. I would, I normally deal with questionnaires. So the kind of data that I'm looking at is questionnaire data. And let's talk about online questionnaires, because they're nice examples of cases where there could be lots of missing data.
values.
Yeah.
Yes.
So what happens with online questionnaires is people start answering, and then they start dropping out. So, and you can see it section by section. You can literally see 300 start. By section B, there's only 250. By section C, there's 200, and there's only 200, and so on. And so you can see the numbers dropping. Sometimes they drop significantly, sometimes depending on the questionnaire. So what I do is, because when you're analyzing the variables that you want to analyze, if your dependent variable is in the last section, you're not going to have information for that dependent variable for all those people that have dropped out before they get to the end. So I will eliminate those cases. I'm not going to work with them because I haven't got data for them. So what I tend to do is I calculate valid, I count how many questions people have answered in each section. And then if they've answered sort of fewer than half the questions, or if they haven't answered more than half the questions, or more than 75% of the questions, I will eliminate them from the analysis, because they haven't finished they haven't kind of finished the questionnaire and so on. And you can't analyze if there's no data for a variable. I don't like this idea of imputing information when you don't have any information to impute for particular individuals. So it's almost like you're making up their result for them. That's the one scenario, but that's where there's no information at all. The other scenario could be where you've got some information, but it's not complete. So let's say there's 10 questions measuring self-esteem, and the person only answers 7 or 8 of them. Then there are ways we can fill in that data, because we've got information for 7 of the variables. We just need to then sort of estimate. So we do have some information there to estimate. And then there's different ways, there's different procedures we can use. So you could use a mean, although that's not considered to be a good option. And then there's also a process called maximum likelihood, which is a process.
You also use it.
Yeah, so I would normally use that process because it seemed to be more accurate than the mean imputation, for example. Yeah, so those are so there are different ways we can, and I think I've got a couple of papers on imputing missing data. So I've got other colleagues who just delete all the cases with no data. So if there's any missing data, they'll just delete the case. But I don't agree with doing that. I think it's not really the right approach, because you should be able to, if you've got enough data, there should be a way you can sort of impute the information.
It's always good to also justify the reasons why you are dropping certain columns or data set. Because sometimes dropping, now you are skewing the data set, and it's no longer going to reflect the true meaning of what you wanted to.
Yes, yeah. So I have a colleague who had a sort of a dispute with a supervisor, because my colleague is the student and the supervisor. Because he had some medical data that he was working on for his analysis. It's a statistical based project, it's the health data is being used to demonstrate a statistical procedure, but the health records had lots of gaps in them. So there was no data for some of the information that so they might not have the sex of the patient, and they might not have the blood pressure of the patient, that kind of thing. So he just eliminated all those records because there was no data there. And then the supervisor was saying, oh, he should have imputed the information. But the thing is, I don't believe in, I sort of agree with my colleague to say, if you don't have anything to work with, you can't just kind of make it up, so it's a bit of a tricky thing, but but hopefully it's not it's not, I think with the work, most of the work that we do, it's usually quite easy to see which cases you should eliminate and which ones you should keep, based on how they've, what they've answered and so on.
No, it really sounds like some of the techniques or methods that you are using in this case, we're also using, because sometimes I'll also use mean or median or more, depending on the type of data I'm dealing with. But if I see that now I need to apply other maybe advanced methods, then I will also look at the maximum expectation and all of those things. Yes. Because also you have to think about the biasness and all of those things when you are yes, when you are replacing the missing values.
I think it also depends on how much information you have to replace the missing data. Because if you don't have much data to do the imputation, then the imputation is not going to be accurate. So that's you're going to end up sort of getting sort of bad data, basically. If you've got lots of data, then the imputation is much more likely to be accurate. So that's the other thing to think about.
With big data, it's always good, because sometimes I'll get big data, maybe let's say healthcare emergency data, then I'll get big data for private hospitals, but for public it's a different story, because we have to go and sit there and capture the data, because everything is manual. So sometimes you find out you have only 10,000 rows, then you also need to apply other Gen AI techniques or LLM to expand the data as well.
Yes. 10,000 records sounds like a lot.
But we always expand it, because we have all these large language models that we can use to expand the data if there's a different type of perspective that we want to uncover from the data set.
I'm going to ask you to talk about the work that you do when we get to assignment 2. I haven't forgotten about you. Just remind me.
Thank you.
Okay, good. Okay. All right. So just bear in mind that the sampling method that the student uses might be, I'm just making a point here about convenience sampling, which is the sort of weakest method of sampling. And it might be difficult to publish work which has made use of convenience sampling. It's not impossible. Obviously, sometimes you have to use it. And if it's a good project, if it's a good, interesting topic, and so on, the work would be published. But some people would look down on convenience sampling and say it's not a good method to use. I think that's partly why people say that they're using purposive sampling as well, when in fact it probably is convenience sampling. But that's it's. At the ethics committee, there was a proposal last month which was using, which stated quite clearly they were using convenience sampling. And it was a nice study, and I'm sure that'll get published, because it's a very nice topic. So sometimes what I suggest to students when they're using convenience sampling, when they say that they're going to use convenience sampling, is to try and sort of shift the research so that they might be comparing a group, doing some group comparisons, and then they're using a quota sample rather than a convenience sample. So it's got more focus. But it doesn't have to be. Sometimes it's the only method that's available for the population and the type of research that's being done. Okay, so let's ask you some questions quickly. What sampling method would you use if you want to generalize about your research? So remember, we've got sort of quite a few different sampling methods we can use. We've got probability methods like simple random sampling, stratified random sampling, systematic sampling, cluster sampling. And then we've got non-probability methods, which are things like convenience sampling, purposive sampling. So if you want to generalize from your research, what kind of sampling method would you think about using? Any suggestions?
Yes. Can I say something?
Yes, yeah.
I think when generalizing your research findings into a larger population, for example, the best one, or the one that I would use probability sampling methods. Why? The probability, as we discussed, probability sampling method, it ensures that every number of population has known and they've got equal chance of being chosen or of being selected in the study.
Yeah.
So yeah, then it reduces biasness, or it minimizes biasness, and it increasing your external validity.
Yes, great. Yeah. Yeah. So you'd think about using a probability method if you want to be able to
Yes.
generalize about a population. Yeah. But bear in mind, it's also related to the sample size and to the so you'd have to you'd have to kind of make a link between the sample size. So it's not just the method, it's also the size of the sample as well, which would allow you to generalize. So it's not just about the method itself, it's also about how. So if you used a random sample to choose a sample of 10 objects from a million, that wouldn't necessarily be generalizable. So even though you've used a random method, the sample size isn't big enough to generalize. So it also fits into that, going back to that sort of required sample size for a given confidence level and margin of error. Okay. But a probability method would allow you to generalize. I've just made a note to myself because I've got a.
And can I say another thing? Because the reason I'm saying non-probability sampling, it is because if you go back to the discussion that we had Thursday, I always refer last week.
Yeah.
The discussion that we have on Thursday, we spoke about non-probability sampling. And non-probability sampling, it won't be an ideal for generalization because it's not easy to generalize to a larger population due to the selection of biasness. For example, we spoke about purposive sampling. We talk about non-probability purposive sampling, for example, which is one that I use, which you select based on specific characteristics for you as the researcher to get in-depth understanding from your participants. So that's why I'm saying it would be much better to use the probability sampling, not non-probability sampling, because it's not easy and it's quite difficult or too vague to generalize to a larger population due to the selection of bias, because in non-probability sampling, you tend to be biased. That's what we said last week. We tend to, okay, I'm going to select 10 out of 20 students in the class, and I want to select the student who understand the module who have done quantitative studies, not students who haven't done the quantitative, because I need the rich data. I need a comprehensive data. I need data that speaks to my research. So I don't want to just select people who do not have understanding of what you are conducting.
Yeah, perfect. Okay, yeah. So yeah, I just want to. I'm going to. This idea of generalizing is quite interesting, and I've got a old paper from many years ago. I think I'm getting my papers mixed up, but I've got a paper where they talk about generalizing from case studies. So even though we kind of make the argument that you need a sort of big representative sample to generalize to a population, there is I'll try and find the paper. I've probably got a paper version of it, not a electronic version, but I'll try and find it for you, because that speaks to this idea that although we kind of make the argument that you can only generalize from kind of quantitative big studies with probability samples, It might also be possible to generalize from case studies, which are more quantitative usually in form. So I'll try and find that for you, and I'll, if I can find it, I'll put it. I should be able to find it on the internet actually as well, if I can't find the original version. Okay, it's just, and I'll post it on the discussion forum, just to give this idea that, you know, we shouldn't not think about generalizing just because we don't have a quantitative probability study type of thing. Okay. The second objective is, what kind of sampling method would we use if we want to compare a measure for two groups? So we want to compare two groups. What kind of sampling method would we use for that? So we want to compare performance for students, first-year students and postgrad students, for example. What sampling method would be used for that kind of study?
Can I try, Doc?
Yes, yeah.
I remember last time we spoke about stratified sampling, to say it ensures that if you're working with groups, it will ensure the groups are represented adequately or equally.
Yeah, that's a good. Yeah, that's a good suggestion. Yeah, that's one answer. Okay, so stratified random sampling is a probability method. Is there a non-probability equivalent that we could use if we don't have a sort of, what is there another option? So stratified random sampling is one correct option. Is there another alternative that we might be able to use if we can't use a probability method?
Okay.
Anybody else have a suggestion for that?
I was going to say stratified sampling, and the quota sampling. The quota sampling, it would be acceptable if the probability sampling is not suitable or is not possible. Remember last week we spoke about that, like we spoke about non-randomly to fill quotas for each group. So I think it would be easier and faster than stratified random sampling. Then we will ensure that we will ensure the group representation. So I think the quota sampling will be also suitable if you want to compare two different groups.
Yes, absolutely. So so we have a non-probability and a probability method for comparing groups, and obviously that would be more than, if you wanted more than two groups, you could also use those methods. So if you're doing an experimental design where you have 4 groups that you want to compare, then you could use stratified random, or you could use quota sampling, because both of those methodologies are focusing on making sure that you have representation from different groups in your sample. Okay, good. If your objective is to explore experiences of a unique group of individuals, what kind of sampling strategy could we use for that kind of study? Corin, are you having a go at this?
Yeah, I was going to say that would be purpose. I always battle to say the word purposeful. Purpose of study.
Yes, purpose of sampling. Yeah.
Yeah.
Okay. Yeah, that's one option. You could also use snowball if you so any kind of I think any kind of non-probability method would work here. Well, except for quota sampling is specifically for comparing groups, but you could use snowball sampling here, and it wouldn't be convenience sampling either, because, well, depending on how many convenience is more general. So the fact that it says a unique group of individuals suggests that it would be more purposive, or possibly you could also use snowball, for example. Okay, if for a study where you want to seek the opinion of an expert, what would that sampling be? What sampling would be used for that kind of design?
Would it not be the same because you're looking for very specific people?
Yeah, so it's purposive. Yeah.
Yeah.
So it's very specific, a very specific target of the person that you're looking for there. Okay, now I've got a test for you. Okay, so we've got we've got different examples here. So 2 of 4 software companies are chosen to participate in a new work at home program. The 5 department heads are interviewed in each of the 2 companies, and then 6 employees are selected at random and complete a self-administered questionnaire by electronic mail. What kind of sampling is being used here? So 2 of 4 software companies are chosen. The 5 departmental heads are interviewed, and 6 employees are selected at random to complete a self-administered questionnaire. So what kind of sampling is going on here? Any suggestions? So there's three things going on here for different units. So if we look at the first one, I'll just go through it. So the two of four software companies are chosen. We don't know how they're chosen. So they could be chosen at random, or they could be chosen based on some kind of non-probability method. So the key thing there would be to explain the process of choosing the companies. Then the next component, which is the departmental heads, that's the second kind of unit of analysis, which is going to be targeted. So all 5 heads are interviewed. So there's no real sampling there. Once you've got into the 2 companies, all the heads are interviewed. And then the 6 employees are selected at random. So there's a random selection, probably a simple random selection going on there. Okay, so that you could potentially. Yes, yeah.
The 5 department heads are interviewed. Out of how many? I think it would be much better to know how many head of departments are there in those 2 of 4 software companies which were chosen to participate in a new work at home program. So now we are told that there are 5 department heads which are interviewed in each of the 2 companies. Out of how many? Or that's why I was puzzled, because I don't know whether out of the 5 department heads, maybe there are 10 or others were not selected. But okay, I assume that there are only 5 heads of interview, because the statement is not telling us that out of 10, maybe they selected only 5 heads of the department.
Yeah, so I would read that as meaning that there were only 5 heads, because it says the 5 heads are interviewed. If there were more than 5 heads, it might just say 5. Instead of saying the 5, it would say 5 department heads. But you would want to check on that. But I would read this as meaning that there were only 5, and all 5 of them were interviewed. But that's my interpretation. Yeah, I think one needs to be very clear about how you write about these things. I was helping a PhD student with her write-up, and she she had a similar kind of scenario as this, where she had schools that she was selecting for her study. And it was quite confusing in the beginning as to which school she'd chosen and whether they were all included or not, and so on. Yeah, okay. But so I would sort of say this 5 heads, that there are only 5 heads and all of them were interviewed, and then the 6 employees were selected at random. So if the selection of the two software companies is random, then this would be then you could say this is a multi-stage sampling. Because and you could consider the companies as being clusters. So that first component would be cluster sampling, where you're choosing 2 of the 4 randomly. If there's only 5 department heads and they're all interviewed, there's no sampling actually taking place there. They just it's like a census of the heads, and then the employees are selected using a random process, probably simple random sampling. So this could potentially be a multi-stage sample if we knew more about the process of selection if the 2 of the 4 companies were chosen. Okay, the next one, 2 rangers at 5 national parks are each asked to recommend 2 other rangers for the study. What kind of sampling is that?
Snowball.
Snowball sampling. Good. Yes, yeah. It's an easy one. Okay, this one is going to catch you, I hope. So to be eligible, students must attend a local high school and speak English. Students with poor attendance record will be excluded. All remaining students will be surveyed. What kind of sampling is this? So to be eligible, students must attend a local high school and speak English. So the study is focusing on students who attend a local high school and speak English, and students with a poor attendance record will be excluded. All remaining students will be surveyed. What kind of sampling is this? Let me help you out a bit. Is there a sample? Is there any sampling process happening here?
Can I give it a try?
Yes, yeah.
Okay. The one that says to be eligible, student must attend a local high school and speak English. Student with poor attendance record will be excluded. All remaining students will be surveyed. I would say it's a non-probability sampling. Why non-probability sampling? It is because yeah, it's non-probability sampling if there is judgment that is involved. This is a purposive or judgment. There's, yeah, because you said if those who are not speaking English or who are not, they do not meet the criteria. So they are not eligible to be surveyed because they do not have understand. That's why I'm saying non-probability sampling. It was because of those who do not speak English or who do not understand or have gist of English, then they will be excluded in the study. So which means as the researcher, you using your purposive or judgmental sampling that, yeah, because they don't meet the criteria. So that's all that I can say. And also, I would say that the population is also known. You know the population, and you have scrutinized or looked everyone to see who is eligible to participate in the study, because your goal is to ensure that our goal is to ensure that in research, for example, when we collect data, we get information so people don't leave blank spaces, for example, in your surveys because they don't understand the question or they don't understand the English. So that would be a non-probability sampling for me.
Okay. I'm going to disagree with you. Okay.
Okay.
So I'm going to disagree with you, but yeah, it's good attempt. So I think for me, I think we need to look at this idea of judgments, because any research that we do is going to have some judgment involved about what the population and the sample is going to be and who would be excluded and excluded. So I'm not sort of completely convinced by the use of judgment as a sort of argument for choosing the sample. So in this case, I would describe this as a total sample or as a census. And so because we're not really actually sampling here, the research site is a school, and the students. So that's the research site is the local high school, and if we define the eligibility criteria. The student would speak English, and anybody with a poor attendance record would be excluded from the population definition. So of the group that we're interested in. So our population definition is that the students must attend a local high school, they must speak English, and they can't have a poor attendance record. And then all the other students who meet the criteria will be surveyed. And so that word "all," we're not actually sampling the students. We're including all of them. There could be 500 learners here. So it might be a small school. It could be 100, but it could also be 500 learners that we are including in the sample. So for me, that wouldn't be I wouldn't classify that as being a non-probability sampling method. I would say this is a census. Or so based on our inclusion criteria for the population, it's a census, or what some people might refer to as a total sample. And I think this is often something which I find, not often, but every now and then we get projects where the student is trying to say that they're sampling, but in fact they're not actually sampling. They're including all the units in the population in the research site in their study. So this is an example of that, I would say. That's how I would interpret that particular example. Okay, so just be aware of this idea that if your population is defined in that way, and you're including all the units in the population in your study, it would be called a census or a total sample. Okay. And that's, yeah, so there's no real sampling happening here. Once you've defined the population, all the units of the population are being included in the study. Okay, but we can disagree if you like your explanation better, then we can. I must look up about judgment sampling. I think Patton has got a definition, so we must look at that in more detail. Okay, the last example: the names of all teens who have been incarcerated in the past 6 months will be written individually onto a piece of paper. The names will be placed in a glass jar. A blindfolded referee will select 10 names to participate in a focus group. What kind of sampling is happening there?
Is that random?
Yeah, simple random. Yeah, that's simple random sample. Yeah. Okay. So just bear in mind that random sampling there's different types of random sampling. So there's simple random, stratified random, systematic random sampling, cluster sampling. So this is simple random sampling. This is an example of simple random sampling. You've got you list your population as the teens who have been incarcerated in the past 6 months. You take their names, put them on pieces of paper, pop them in a glass jar, and then you pull out the names without looking at them before you pull them out, kind of thing. Yeah. Okay. Good. So those are. So are there any questions about sampling and populations and so on? before we move on to the next session. Any questions? So I think just in terms of supporting students, I think it's important to be able to look at their sampling method. They need to, when they're reporting on their sampling method and deciding on their sampling method, there's certain information that they need to present. So what kind of method, what's their population, what kind of sampling method are they going to use, what size of sample are they going to obtain? Those are all kinds of questions that they need to answer when they're developing their proposals and when they're doing their research. And then, and then I think it's practically sometimes students are not always aware that some of the ideas that they have about their sampling are going to work out in the way they expect it. So I used an example of a student who said they were going to be doing random sampling, and then they were targeting 400 people, assuming that those 400 people would actually answer the questionnaire. But that's that. So I think it might be possible that they could do the random sampling that they said they were going to be doing because they were working in an organization. So that's feasible if they can get a list of names and so on. But the idea that all 400 people are then going to happily participate in their research was not a good idea. So the suggestion would be that they need to target a bigger sample in order to get the sample size that they want. So that it's just sometimes practically things don't quite work out the way students expect them to. Yeah, I think we're always enthusiastic about when we're doing our research. We're always very enthusiastic, and we think everyone's going to want to participate. But the reality is, people don't always want to participate in our research. Okay, I'm just going to stop sharing this for a second. I'm just going to, I think we can take a short break. And I'm just going to change slides. So I'm just going to close this file. All right, so let's take a 10-minute break. It's now 10:31. Let's meet at 10:41 again. Is that all right?
Yeah, that's fine.
Okay, good. Okay.
Thanks.
So 10:41. Okay. Right. I'm going to carry on. I'm just going to share. I'm going to start. Okay, so we're moving on to contact session 4 now. We're getting behind, but it's fine. We'll just have to try and catch up as we go through. So before we go on to the session itself, I just want to, before we start talking about assignment 2 and assignment 3, I just want to talk about supervision. The course is about supervision, this is more, excuse me, we're dealing with supervision in relation to quantitative research, but there's sort of some broader issues around supervision which come into the discussion when we're working with students, whether we're doing quantitative or qualitative research. So this is, and I think this is quite a nice paper by Anne Lee about, it's a paper about doctoral students, and she identifies 5 areas where students develop and benefit from in terms of the research that was done. So the first area is referred to as enculturation, where the student is encouraged to become a member of a disciplinary community. And that fits also with Huff, and I think I need to find that chapter for you, where Huff refers to the student joining a conversation to make it less intimidating for them to join the academic community. The second component is critical thinking, where a student is encouraged to question and analyze their work. And we've all been students ourselves, so you can think about the extent to which we as students went through this process of enculturation and critical thinking and so on. The third component is emancipation, where the student is encouraged to question and develop themselves, in other words, their own sort of development as a sort of a new academic. The fourth area is developing a quality relationship, where the student is enthused, inspired, and cared for by their supervisor. And then the fifth dimension is functional, and that's one about project management and so on. So, and that, as a supervisor, we play a role in all of these different areas to a sort of larger or a smaller degree. A lot will depend on the student and how much time they would spend sort of interacting with a supervisor as well. But I think it's quite an interesting paper, and if as supervisors, it's good to think about the role we play in terms of, say, developing a quality relationship with a student. My experience, I've been a supervisor, and I work with supervisors who are supervising students. So I have a good understanding of the kinds of relationships that can develop between students and supervisors. Yeah, it's interesting to think about these things in more detail. Yes, Mfundo, yeah.
Oh, I was saying, Doc, we have also I think we also covered this in our academic literacies,
Yeah.
where we looked at both Annie Lee's 2008, 2015, and 18 papers. It's the framework. Yeah, it was the framework. It was in a table format where we had to discuss the functionality, enculturation, critical thinking, emancipation, and developing developing a quality relationship. I think it was basically about us as supervisor and our supervisees as well. It speaks both to us as supervisor and supervisees. Like, for example, where we like assist student in terms of okay, that framework speaks about that. Okay, we are not just supervisors, but we are the mentors of the supervisees, and in terms of gatekeeping information. So it was quite interesting, and I think we did an assessment about this as well.
Okay, good. Yeah. Okay. Yeah. So I introduced this when I started doing the module a good few years ago now. So somebody else must have seen me using it and decided to use it for their module as well, which is good. Okay. Okay, so I'm glad it's being used, and just yeah, so that's good. Great. Okay, so I'm not going to sort of spend a lot of time talking about the sort of philosophy of supervision in this way. It's more about yeah, sort of expertise in quantitative research that we're focusing on in this particular module. But as part of talking about the processes, we'll cover some of these things anyway. Okay, so assignment 2 is about I'm just going to just have a look here what I've got here. Okay, so I'm just going to stop sharing this screen and move to assignment 2. So assignment 2 is about, let's find it. Okay, so it's kind of looking at the supervisor as an expert, and the focus is on validity and reliability. So what I'm asking you to do for this assignment, it's not a particularly complicated assignment, but so it's the topic for the assignment is validity and reliability in your research field. And what I'm asking you to do is to find two research papers in your field, and to go through those papers and evaluate what the researchers are saying about validity and reliability for in those papers. So it's really focusing on the supervisor as an expert in research design, and part of research design is validity and reliability, and it's kind of evaluating as a supervisor. You then need to evaluate whether your students have done a good job in terms of describing the validity and in terms of dealing with validity and reliability for their project. So this is kind of an exercise of doing that, but with kind of formal research rather than with a student project. Partly because it's easier to find research papers than it is to find student proposals. Okay, particularly in specific areas. So so what you need to do for this exercise is you need to identify and define the forms of validity and reliability within the paper, and then also explain how validity and reliability are covered in your discipline, because there might be different ways of covering validity and reliability depending on the discipline that you're working at. Identify threats to given forms of validity and reliability, and then propose steps to mitigate the threat. So if the researchers that you are reviewing the papers, what kind of validity do they talk about in the paper? Do they identify threats to that validity, and do they propose what steps do they take to try and mitigate any threats to the validity? And then also the final component is to reflect on how your students could learn about forms of validity and reliability, about the threats to those validity, and any steps to mitigate threats. So how do students learn about validity and reliability, and how do they, given that they're new to research and they don't know a lot about research, how do they learn about these concepts, and how do they integrate them into their research? Okay, so there is so you need to choose 2 articles. You can choose any 2 articles that you want. And if the articles don't have anything about reliability and validity, that's also fine, because then you can simply say that they haven't included it and this is what they might have been able to include. So it's not, you don't have to specifically look for papers which have got coverage. Most papers will have coverage of validity and reliability. They might not express it specifically as that, but you can then infer from something that they're saying that they're talking about, or they're meaning that they're speaking to the validity, even if they're not necessarily mentioning validity specifically. You need to list the references in the 2 articles. Yeah, so you need to let me know which articles you've used for the exercise. And both the articles must make use of quantitative-based research design. Okay, because remember, this module is focusing on quantitative research where validity and reliability are important. So you need to focus on 2 quantitative projects. So you need to critically review the 2 research articles for themes of validity and reliability. So you need to focus on those 2 concepts, extract the information about those, and then you, as I mentioned, they might not use the words validity and reliability, but they might be using other terminology to refer to those concepts. And then you have to answer these questions. So what forms of validity and reliability are covered in the research papers? So if they are covering certain forms, you need to list the forms. And then also answer the question, are there any forms of validity or reliability that are not covered, that they could have maybe covered? And then if no forms of validity and reliability are covered, what is the implication for the quality of the research? And what could the authors have included in relation to that? The next question is, are the forms of validity and reliability correctly defined? Because sometimes researchers don't always define concepts correctly in their papers. If you say yes to that question, what is your evidence for that? If they're not defined correctly, what kind of definition should they have been provided? And then do the authors identify and explain possible threats to validity and reliability? If they do, what do they mention, and so on? So those are some of the questions that you can answer there. And then yeah, so then just a reflection on your own research and supervision. Are the forms of validity and reliability that these authors cover relevant to your own research and the research that your students are doing? If yes, why? And if no, why not? What other kinds of forms of validity and reliability are you covering? And then as a supervisor, how would you facilitate student learning of these forms of validity and reliability? Okay, so one of the things that I find is that the textbooks generally don't have a lot of coverage of reliability and validity, the sort of research methods textbooks. And that's where the student might start to find information. Obviously, there's websites and things as well, but it's also that validity in particular is quite complex in terms of its definitions and so on. So how would a student kind of learn about these things? Okay, I'm going to give you a chapter by Knapp and Muller, which is the reliability and validity of instruments, and that's a supporting resource for this assignment. And it provides a brief overview of reliability and validity in the context of quantitative research design. And there's some questions that they ask that they've got some desiderata for what researchers should use when they're talking about reliability and validity. So you need to produce a short report, which has an introduction, the citation of the 2 research papers, a critical review of the coverage of validity and reliability in the 2 papers, a reflection on your experience as a researcher and supervisor in relation to validity and reliability, and then a short conclusion, summarizing the main insights from your critical review and reflection, a reference list. And I think the due date is Monday, the 6th of October. Just check that date. I might have I think it's correct. So that's assignment 2. There is a rubric for assignment 2. I'm just going to share it quickly. So where's the rubric? Assignment 2 rubric here. So this is the rubric that you're going to use when you're doing the work. So there's the introduction, there's identification of forms of reliability and validity from the papers, your evaluation of the forms of reliability and validity that were used, and so on. So, and a reflection on the relevance and then the discussion, your discussion on how to facilitate student learning on reliability and validity. So how do we get students to learn about these concepts? So that's the rubric for assignment 2. So just have a look at that when you are doing the assignment. Okay, so that's assignment 1. Assignment 3, sorry, that's assignment 2, I beg your pardon. And then assignment 3 is the exam equivalent. So that that's not the wrong document. I want to show you that. Assignment 3 is a portfolio that you're going to develop, a toolbox. So this is kind of combining the supervisor as an expert and evaluator. And what you need to do for this assignment is you can start doing it now, is curate a toolbox of resources that you would use as a supervisor for your students who are conducting quantitative-based research projects. So what you need to do is, so as a supervisor, there's certain resources that you might use to share with your students to help to guide them in terms of their development as quantitative researchers. So this assignment is asking you to you might have some tools already that you use, so you could integrate those into this assignment. And as we go through the module, you might find tools that you think are going to be useful for students to use in their development as quantitative researchers. So that's what this assignment is about. It's about collecting some resources together for a toolbox, and then I'm asking you to answer some questions in relation to those resources. So the first thing is, so you need to so the objectives are for you to identify important resources in relation to quantitative research. And those would sort of enhance your ability as a supervisor to either help a student learn or to evaluate a student's work. So there's 2 components to this. One is a resource that might be good for the student to use, and then the other component is a resource that you could use to evaluate the work that the student is doing. So there's 2 parts. There's two elements that you need to collect for this. Then you develop a toolbox, and then you reflect on how those resources can be used to develop. So I want you to kind of justify why you've chosen that resource for the student. Then this is your exam equivalent. And then, so you need to identify resources for 2 purposes. One would be knowledge resources. So that's resources to support the student towards their understanding of excellent research design and implementation. The second component is evaluation resources, which we're going to support you as the supervisor towards evaluation of the work completed by a student. And I'll give you examples of those. So you need to identify 5 knowledge and 3 evaluation resources for your toolbox. So you don't need to collect hundreds of things, just 5 knowledge-based things that you think are most useful, and 3 evaluation resources. It must be for the resources must be for quantitative-based research or mixed methods, not qualitative-based. Okay, so we're not focusing on qualitative here. And the resources must be relevant for your discipline. So some resources would be, will cut across discipline. So if you, just using an example, if you wanted to use the chapter by Wetton on developing theoretical propositions, that would be a good resource to use for students. That could apply in any discipline. It's not something that's particular for social sciences or for law, for example. It could be used in any discipline. So some of your resources could be very specific for the discipline that you work in, and others would be maybe more general, but that could be used across disciplines. So I'm not, you don't have to be restricted here in terms of, when I say it's relevant for your discipline, it doesn't mean that it has to be discipline specific. It can be a general resource that could be used in your discipline. So that's what I mean by relevant to your discipline. Your knowledge resources can cover different stages of the research journey. So it could be about the conceptualization of research, the theoretical framework, your research design, your population and sampling, operationalization of measures, data collection, statistical analysis, writing up results. So your knowledge resources could come from different stages of the research journey. They don't have to be on one stage only. So don't just choose resources which are about theoretical frameworks only. You need to kind of, when we support students as supervisors, we need to support them at various phases of the journey. So don't restrict your knowledge resources to just one phase. And then you can use any form of resource. So you could use a publication, a book, a journal article, you could use a video, you could use a workshop, you could use a course, you could use a website. Anything that you think would be useful for your students to learn about quantitative research can be used there. So for example, there's some very good websites with some really good material for learning about quantitative research. It might be a video on how to, a website on how to use SPSS, for example, and that's something that you could include if you think it's something relevant. Okay, and then for each resource, you need to include a brief, clear description of the resource, justification for why the resource is relevant for quantitative research in your discipline, explanation of what phase of the research journey the resource is useful for, motivation for why you've chosen to include the resource in your toolbox, an explanation of how the resource will be shared with and used by the student, and an explanation of how the resource will be used by yourself, and that's an evaluation resource, and an explanation of how you will evaluate the effectiveness of sharing knowledge resources or using evaluation resources. So the reason for that last point is that sometimes we have a resource that we use, but we don't know if the student actually uses it. So, you know, I can give a student a chapter on theoretical propositions, but I don't know if the student is actually going to be using it. So what kind of checklist or what kind of checkbox would you put in place? What kind of strategy would you put in place to make sure that the student is actually making use of the resource? And that's kind of pushing it a bit further there. And then this is a description of the product that you need to produce, and yeah, so there's various things, and then there's also a rubric for that assignment, which is assignment 3 rubric, which is here. So it's your listing, it's the justification for the resources, it's the explanation of how the resources will be shared. It's your supervisor resources, a listing and description of those, justification for the resources being relevant for the discipline, and so on. For these supervisor resources, which will help you evaluate, I've got an example of a paper. I might have shared it with you already, but it's basically it's a research article which has there's various research articles which give you guidelines for how to evaluate a research project, for example. I have a book as well, which I'll try and scan some chapters from that book for you. It's a recently published book about evaluating research. So it could be something like that, and they've got exercises in the book where you can sort of do exercises to help improve evaluation skills, for example. So something like that is what you could use as the resource to help you evaluate the student's work. So it's kind of developing yourself as an evaluator of student work. So when I look at a proposal, I use, if I look at the ethics proposal, if I look at proposals for the ethics committee, I attended a workshop where they gave us various kind of criteria that one needs to look out for, and I use that set of criteria. So that's something that I would put into my toolbox as a tool to use. It would be that set of criteria that I'm using to evaluate the ethics of a project. So that's the kind of thing that you're looking for there. Yeah, so that's this is the rubric for the marking of the assignment 3. And that assignment has a due date. I can't remember exactly when it is now, but that's a very strict deadline. I will get into serious trouble if you are late. And you will also get into serious trouble if you're late. So please focus on that. Start collecting your resources now, so that you're ready to hand in on that that deadline, because that's a very strict deadline for faculty and so on. Yes, Mfundo, yeah.
Sorry, Doc, how many our assignments do we have for these modules?
There's 3. So you've done one. You've done one already. Yeah. The second one is due. The second one is, as I've described, where I'm just asking you to review 2 journal articles for validity and reliability, and to sort of talk about that in relation to your discipline, and are you doing things differently? Are you using the same types of validity and reliability, that kind of thing? And then the third assignment is the exam equivalent assignment, which is the toolbox of resources that you're going to put together to help students.
Are we going to have presentation? There's no presentations for this module.
No, unless you want to do one, but yeah. So you can just
There's another thing that sorry, Doc, to cut you or to disturb what you are saying. I think the due date for the third assignment, it says the 25th of October.
Yes, that's right. Yeah.
We've got academic literacies as well, but we'll see. We've got academic literacies as well. We're submitting on the 25th of October. It's the final assignment. We're going to have the presentation on the same day, and we'll submit the final assignment, summative.
Okay, let me speak to the administrators, because they gave me the date. But if you've got something else on that same date, then that's a problem. So I don't think they should be putting something on both dates. But I was just given this date by the course coordinator. So let me discuss that with them. Yeah. And because I'm not aware of what the other modules are doing. So normally we don't have something on the same date. So I think there's been some communication.
For the other module, we've got a presentation and a portfolio of evidence to submit. So it's quite a lot due on that date then.
No, I think somebody's made a boo-boo with the dates then. But let me speak to the coordinator, and then I'll revert back to you. Yeah. I know they're just very strict with the final dates because of the faculty want marks and things, so we don't have a lot of time to mark and then external, and then get because the faculty gives us deadlines for getting things in on time. So that's probably, but let me talk to the coordinator and find out why we've got so much going on one date, because that shouldn't be happening. Yeah. So unless the other facilitator changed the date for that, but then we should be communicating about it, not sort of making everything happen at the same time. Okay.
Yes, the other facilitator changed the date. It was initially the 18th of October. However, a lot of students were not available on that weekend. Okay. Some are relocating, and some they've got commitments to do. Then the availability of students, it was very low. So as a result, we had to push it to the 25th. However, she didn't take the decision on the day. She consulted with the person that the one who gives you the dates to submit your So I think the person who mixed up the dates is the coordinator for the program. Yes.
Let me discuss with them then, and we can. They might ask you to then. They might ask me to move to the 18th, but let's just see what happens.
That won't work.
Yeah, let's see. Yeah, let's see what we can do. Yeah, we've also got a conference happening that week. So there's or soon, yeah, but that's okay. We'll see what's going on. Okay, let me discuss with the coordinator, and then I'll revert back to you about that date. But so in the meantime, just carry on working towards it. So what you need to be doing is building your toolbox. So as we go through the module, there's already a few things that you could have used already for your toolbox. So for example, just to use an example, you might think that the chapter by Wetton on developing theoretical propositions is a very good chapter that you would share with students to help them understand about theory and how they might develop new theory, for example, or how they might test an existing theory or build a new theory. So that would be something that you could put into your portfolio. But as I said, it doesn't have to just be research papers or publications. It could also be something off the website. There might be something, there might be ethics training that you say that the student can do some ethics training, for example. I'm not really dealing with ethics in the module directly, but I don't mean directly, but I mean in a lot of detail, because it's not about ethics. But it could be that you might say, if you want the student to understand about the ethics around quantitative research, they could do an ethics program online, for example. There are these ethics programs online that we can do. So that could be something, if you think that's important for your area, then that would be a good thing to suggest, yeah. Okay. All right. So if you have any questions about the assignments, just either email me or we can arrange a meeting if you're not sure what you're doing. But we are working under quite tight time frames. I don't know where September's gone. It's just disappeared. but and October's they're literally around the corner. So just so just work quickly, efficiently, and start. Just do a little bit of work on your projects every day, and then you won't be panicking at the end.
May I ask a question just
Yes,
in terms of assignment 2?
Yeah.
In the 2 articles, you have given us about 4, 3, 4, 5 articles. Do we need to use those ones, or can we look for any ones?
No, I think you must use articles that you're interested in that are related to your field.
Okay.
Because it's going to be much easier for you to work with those than it would be to work with something that I choose for you.
Okay.
So what I'm suggesting is that, if you work in, let's say, for example, you're in nursing and you work with a particular topic, then choose, find 2 quantitative research articles on that topic. So it'll be easier for you to engage with the articles. Yeah. I'd prefer that you choose the articles than I give you something that's not familiar and that you're not really engaged with, because then it's more difficult to kind of work out what's going on with the research. Yeah. So you can choose the articles. It's in a subject matter that's of interest to you, as long as it's quantitative. Yeah. Okay. So yes, yeah.
Can I select a mixed method? Because in my discipline, it's difficult to find an article that is strictly based on quantitative. So it's either a mixed method or it's simply qualitative.
Okay. What discipline are you in again?
It's media and communications.
Okay, I'm sure I'd be able to find some quantitative papers, but no, that's fine. As long as they, mixed methods makes the reliability and validity a bit more complicated, but that's fine. Yeah, if you, and maybe that's something for debate actually, if there's not, if mixed methods is not introducing the validity and reliability, then that's also making a point actually. So that's fine. Yeah.
Okay.
I'm always a bit suspicious when people say there's no quantitative research, because I'm sure there will be, but that's fine. Okay.
No, I'm not saying there's no. It's just that
it's difficult.
the number of articles that I've read in my field, in media, in journalism, in PR, in brand communication. But I'm gonna check in other, maybe the discipline that are closer to what I'm doing, like your marketing. I know in marketing, there are people that are doing quantitative, strictly quantitative, especially those who are looking at the customer satisfaction or customer, or they do quantitative. I'm gonna look at that. But when it comes to my discipline, in media and communication, journalism, new media, and it's basically people doing your qualitative research, and so you hardly come across with an article that is strictly quantitative. I don't know why, and I think it's because we understand it better qualitative over quantitative because it's not our specialization. However, I'm gonna look at it. I'm not saying that maybe I will look at it, then I'll think about other articles maybe that I might come across. But I know two articles that I've read, that I've cited in my paper. The authors used a mixed method. So I'm going to look at if maybe there is a paper that they have used that speaks to communication, media and communication, and they've strictly used only quantitative. I'm not saying that there is no, or there is no quantitative in our discipline. It's just that it's rare to come across with quantitative.
Sure. No, that's fine. Okay. I think I did mention mixed methods as well. So it's fine. Yeah. Okay. Just as long as there's some quantitative dimension to it, that should be good. Okay. So Teboho, I wanted to ask you just to, because you work in a discipline where you're working with records, for example, more than sort of people-based. I mean, obviously the records will be based on maybe what people do, but can you just tell us a little bit about the kind of work that you do and what kind of methodology? And then I'm just a bit concerned about your discipline in terms of whether they would cover validity and reliability. They should, I would think they would, but just tell us a bit about the work that you do.
Okay, thanks, Doc. So in my discipline, it's more of data science and engineering because that's my background. But sadly, I'm working in applied applied information system department, which is sitting under a CBE. So we mainly in that discipline, we mainly use Sanders Research Onion in terms of aligning our research methodology. But from my discipline, because I also work a lot in the Center for Applied Data Science. So basically, they will work with secondary data set. It doesn't matter what type of data. It can be raw, textual, images, or any type of data. Then we apply different AI techniques to actually analyze or to come up with also some artifacts at the end of the analysis that can be used. So in that space, we use design science a lot, and we also use what we call the Scripps DM methodology for data science research on how we need to carefully prepare our data before we can even start to design any type of predictive model to be connected to a specific interface, or connected to whatever artifact we are working on. So what we do, I think in terms of data pre-processing, we're more or less aligned on what we do to make sure the data it's well prepared for whatever analysis that you want to conduct. Then when it comes to the validity and reliability, in our case, what we do, we use evaluation matrices. Those matrices, you use them to analyze the final results of whatever model that you would have generated, to check how many errors, or if you are actually using the model or the technique to predict if a patient is admitted or not admitted, looking at whatever record that represent that specific patient. Then we will also use those matrices to check if our model was actually how how accurate was it in predicting if the patient should be admitted, looking at whatever symptoms, or the patient should not be admitted. Then we also will go further after we use the evaluation matrices where we check the accuracy, we check precision, we check the recall and the F1 score. So those are some of the things we use. And then we'll go an extra mile again to do the post evaluation, where we use what we call explainable AI, where now we need to, because these more type of models that we do, they are more of black box. So normal human being who's not in our field, they might not even understand them. So the explainability now goes and read each record and explains it in simple English to make sure that even a clinician, when we show them the findings or whatever artifact we have come up with, then at the end of the day, they also understand what the actual predictive model did to come up with the final results of that model. Then if they are happy, then we will now design an artifact we connect it to that model. So it's one of the things that I'm busy doing with nursing department. We have a student there. I'm supervising with one of the colleagues. They're designing a machine learning model for nurses. So with them, what we did, we started, because of their field is more social science. So we had to do focus groups and all of those things to get more information of whatever issues or concerns that they have as nurses in that public hospital that we have identified that we're working with. And then my part as part of the supervision team, it's when we come to designing the machine learning model. So the focus group is the first part of the data collection. We do mixed method. And then now, whatever issues that will be raised from the focus group that we're going to synthesize, then we're going to use those issues to identify what type of data set or raw data we need from that hospital. And then we're going to use that data now to try and propose a model that can be usable or can be accommodate some of their issues, because we can't address all of them. I hope that makes sense, Doc. I'm not rambling.
No, it's fine. But what is the purpose of the so when you're talking about the nurses in the hospital, in the public hospital, for example, what is the idea behind the research? Is it to kind of help solve the problems, or
yes, the problems they have, overcrowding, maybe in terms of the nurses, let's say in the emergency care unit, the delays, there's always those delays, and some of them, their work, their admin, it's manual. So we try, maybe if we see that the main backlog is that they have to allow the patient to complete forms, then why can't we come up with an interface that can allow them, if a patient has visited that hospital, let's come up with an artifact that will allow them, or a system that will allow them, when they punch the patient's ID number or whatever, then it can populate that record immediately and show the history of what that patient was there before.
Yeah, okay.
So that every time when you go to the hospital, we have to complete a form, that admission form.
Yeah,
so maybe that could be the issue as well of why, or maybe it's resources.
Yeah, so it's actually looking at processes and saying, system. It's actually looking at systems and saying, is there a way we can improve the system?
Yes, we also do a lot of observations as well in some of the studies, because I also do another study in water, running water, the one for sewer. Yes, I'm also doing that as well. We got data from Krugersdorp municipality, somewhere there. So we look at those type of issues, and then we also do a lot of walkthroughs, because if we apply in the design science, then we have to follow it to the T, from the first stage to the last stage, where we now unpacking it to get to the point where now we bring in the user to say, can you now test the artifact, because we went through the whole process with you, and then now we want you to test the artifact that we have come up with, and if there's any interest, then we can take it from there.
Okay. Because I was it's very interesting, because I was thinking, like, with the water situation in Joburg at the moment, that I mean, the Joburg water takes reading every month from our properties, and
Yes.
obviously it doesn't work for everybody because some people won't have meters and But
Yes.
I can't understand why they can't sort of take that data, because it must be somewhere in the system, and say, okay, well, let's identify the houses or the households or the buildings that are using a lot of water and go there and see if we can't get them to use less, kind of thing, or whatever, instead of just sort of sending out notices and saying, oh, you're using too much water. But anyway, or don't.
And sometimes you find
anyway,
that there's a leak. So sometimes you find that there's a leak somewhere in the pipelines or things like that. So that type of data, some they agree to give it to us, but some you have to go an extra mile to get that data. There's a lot of processes that you need to go through. So sometimes we struggle to get data as well, but we're trying to communicate with the right agencies as well.
Yeah, but you will be able to, but you do have, there are processes in the research that you do where you look at the quality of the data and the accuracy of the data and so on. So that's fine, because then.
Yes, we do.
Then you
because
do
we
have
need to make sure that the data it's well cleaned, and it's in a form that when we push it into the algorithm or the machine learning or the AI, it knows what it needs to do. If we are working with images and we are identifying, looking at patient lung images, then those scans, we also need to make sure that we don't end up saying this patient, we have detected cancer, even though it's not there. So we need to also make sure the images are also cleaned up very well. And then by the time you now to start to identify if that image shows the signs of cancer or signs of something with the patient, then we have really prepared the data thoroughly to make sure, we don't produce wrong results as well.
Yes, there'll always be some error, but you want the error to be as low as possible.
Yes, then we use those statistical methods to also tell us the errors and all of those things. Then we take it from there to say, no, if this has a lot of errors, then it means we need to go back and maybe consider other data pre-processing techniques that we can use to prepare the data to make sure it's ready for model generation.
Okay, good. Okay.
Yes.
Right. Good. Thank you very much. I hope that's interested other people in systems analysis and large data sets.
Okay. We're just generating different models to solve different problems.
Okay. Thanks very much, Teboho. Okay. Sorry, just a question. How many people are in the other class that's due on the 25th? How many people are in that group?
Me.
Yes. Sorry. How many?
I think all of us are.
No, but how big is the group?
How many?
Is it like 15 or
20? 15
20.
or 20.
Okay, so they're going to get they've got size on their side. Okay, right. Okay, no, that's fine. Okay, thank you. Okay, so so I just wanted to say, so I'm going to move on now. This is just some additional resources. I'm going to put some resources on experimental design in Moodle, and I'm also going to share with you a research paper, which is a tool for supervisors for where they've got an assessment rubric for research report writing. So that's something that you could use as part of your, if you like that paper, and if you think it's useful for you as a supervisor to improve your sort of work as a supervisor evaluating student work, then that would be something that you could use. So that's I'll put those on the, I think I'm going to post the stuff in the discussion forum, and I'll send a message when that goes in there. Okay. Sorry, there's a person H on the, who's H? Is that
Theodora?
Theodora, are you back again? Okay, right. Okay.
I'm saying sometimes I'll use Jake.
Okay, right. Okay.
Either Jake or Theodora now.
Okay, but now it's H. Okay.
Right. I wanted to type Theodora, then it went through.
Okay, good. Okay,
Okay,
good.
okay,
Okay.
Doc.
Okay, so we're going to talk about reliability and validity. I'm not gonna finish the session today if we're finishing at 12, but let's try and cover reliability and validity because that you need to know about this for your assignment. So I've covered this diagram already, but so the plan as a researcher, we're trying to get to that last image, which is the image on the right, which is we've got valid and reliable results. We want to avoid situations where we've got a result which is not reliable nor valid, and where we've got a result which is reliable but not valid. So that we need to avoid situations like that. And it does happen that we do, a student can do research where they get reliable results, but it's not a valid measurement, or where nothing is valid or reliable. And that's not a good situation to be in when you're trying to sort of submit a project for examination. So it's important to both validity is more important than reliability in a sense. But you can see from the middle diagram that if you don't have reliable data, if the responses are all over the place in terms of consistency, it's equally disastrous for a research project. So the key thing is we're trying to get we definitely want to try and get valid and reliable information for our studies. Okay, so just very, very simple definition. Reliability is consistency and repeatability, and validity is accuracy. So that's those are the two concepts that accuracy in terms of measurement, where we say if we say we're measuring self-esteem, that we know that we're measuring self-esteem and not something else. So these are both important concepts for research projects. Yeah, the debates relating to reliability and validity are quite complex. So it seems like a simple concept to say validity is accuracy, but as you'll see as we go through the definitions, there's lots of different types of validity, and there's also different types of reliability. Reliability is a bit easier because it's not as complex as validity, but both concepts have various meanings. So it's not, and there can be very complex debates about these concepts. Quite surprisingly, research methods textbooks don't often give a lot of detail on validity and reliability. Examiners and reviewers will often ask how reliability and validity have been achieved. And students must try and maximize the reliability and validity before they do the research in the field. So they must try and get things right before they go into the field. It's very difficult to correct things once data has been collected. And just we sometimes get asked as consultants. So somebody will design a questionnaire and they'll collect data, and then they'll come along and say, how do we show that our questionnaire is reliable and valid? And sometimes it's not that easy to do that, depending on the design that you're using. So it's sometimes we can answer the question, and sometimes we'll have to say, well, there isn't really a way you can sort of do it statistically at any rate. Yeah. Okay. So yeah, so just a couple of questions. Let's start with the first question. What is reliability? So what do you understand by the term reliability? And how do we, let's just ignore the second part of the second set of questions. So what do you understand by the term reliability, and how do we demonstrate it? Let's just answer those two questions. So what do you understand by the concept reliability? I've kind of given you an answer, but have you, or let me put this another way. Have any of you had any experience of measuring reliability? So have you had to worry about reliability for your work? And how did you demonstrate that you had it? If you had to be concerned about reliability? Has anybody got any experience?
I think you've already
Yes.
said, Doc, when you said that reliability, it can be referred to the consistency in your research results or in your studies results, like your repeatedly results that you find or that you demonstrate in your results. And it means that the methods are used to produce, for example, stable, consistent results over a time and across different observers or instruments that we used in the research.
Yeah. Okay. So yeah, as I mentioned, there are different types of reliability. So that's one of them that you've just described. So we'll look at the different types of reliability in more detail. Okay. So and then I'm just going to skip through these questions because I'm just worried about the time actually. So I'm going to move on from this. Okay. So I've given you for assignment 2, there's a resource that I've given you from the book, The Reviewer's Guide to Quantitative Research. And there's a chapter from that book by Knapp and Muller where they talk about reliability and validity of instruments. So have a look at that chapter. And then it's very important, the desiderata that they mention is that if you're using a measurement instrument, you must describe it in enough detail, in sufficient detail. So you need to give good detail of the measurement instrument that you're using. And then the instrument must be appropriate for the study and the research question. So you need to make the link between why you're using the instrument and why it's appropriate for the research that you're doing. Then you also need to look at appropriate reliability indices. So as I mentioned, there's different types of reliability. So we'll look at those in a second. And then you need to you need to justify and explain why you're using specific types of reliability, a specific form of reliability for your study. An important point here is I just want to make the important point here, and it does come into the argument about when people come back to us and say, how do I show that my questionnaire is reliable? The study's purpose guides the choice of indices calculated from current data and or examined from previous research. So what that's saying is that when you're arguing that your instrument is reliable, you can do it from what you've measured. So I'll explain why I'm highlighting this. You can do it from your own data if you have the right data, but you might not be able to do it from your own data, and you might have to use previous research to argue that your instrument is reliable. So just to use an example, psychologists develop scales which measure psychological constructs. So let's use the example of self-esteem as an example. So you can measure self-esteem of an individual, and if you get enough cases in your sample, you can test the reliability of the self-esteem measure. But if you get a small sample, you might not be able to do that, in which case you would then need to rely on existing research or previous research to argue that the scale is reliable. So you can't do it for your own data, but you could do it based on previous data, previous studies, so for example, a few years ago, I helped a PhD student who was using psychological measures for her study, but she had a small sample of 30, sample size of 30. So it wasn't possible to test the reliability and validity of the instrument she was using because the sample size was too small. So she had to rely on previous research to argue that the measures that she was using were valid and reliable. So sometimes we have to rely on previous research, not on the research that we've done ourselves. So that's an important point. Okay, the third, so suitable validity evidence is gathered. The study's purpose determines the type of validity support gathered from current data or again from consulted from related literature. So again, that's saying that sometimes for validity, we can test the validity ourselves, or if we've got a big enough sample, but sometimes we might have to rely on previous research to argue that the instrument that we're using is valid. So ideally, it would be good to calculate from one's own data, but sometimes it's not possible if the data set is too small, for example. Okay, and then yeah, then the researcher needs to, or the student or the researcher needs to report applicable reliability and validity evidence, and the study's conclusions would be placed within the context of that evidence or lack of evidence of validity and reliability. So if a researcher hasn't given any indication of reliability and validity in their paper, you're going to be less convinced by the conclusions because there isn't evidence of reliability and validity. And sometimes researchers will struggle to get papers published if there's not some kind of evidence of reliability and validity. So those are points to work out. So that's something that you can use as a resource for the assignment too. Okay, so reliability, there's different types of reliability. There's what we call internal consistency. And that's we measure this using a statistic, for example, Cronbach alpha. And this is what we could call item to item item to item reliability. So if you have a set of questions measuring, say, self-esteem, we can measure the reliability or the internal consistency of those questions. The idea being that if the questions are measuring a concept called self-esteem, then the answers to those questions should be consistent. In other words, if a person agrees with a statement, they should agree with most of the statements, and if they disagree, then they should disagree with the statements. So the rating of those statements should be consistent if the statements are measuring a construct. So that's what internal consistency means. We can also get repeatability. So reliability is also known as repeatability. And this would be measured by repeating the research and then testing to see whether we get the same result as the first time the construct was measured. So this is the time-to-time measure of reliability. So you might measure self-esteem before an intervention, and then you measure self-esteem after the intervention, and you see whether those two measures of self-esteem correlate with one another. So that's repeatability. And then there's also reliability of rating. So when you get judges to rate something, we want to see whether the judges' ratings are consistent or accurate, and that's a rater-to-rater reliability. So those are the three main forms of reliability that we can measure in research. So the third one is where you might get often. So let's say, for example, you're doing a health sciences study, and you want to see how well a new radiographer can analyze an image. So what you would do there is you get the new radiographer, the student radiographer, to analyze an image, and then you get an expert to analyze the image. So you've got two people analyzing the image, and you want to see how closely their results match. So that's what we do. That's when we deal with consistency of ratings or scores. Or you might have two people examining a assignment, and you want to see how closely their marks align. So that's yeah. Or you could have three people reviewing a proposal for an ethics committee. Do those three people give it the same rating? How consistent are they with their ratings? Okay, so those are the three types of reliability we can measure. Okay, so I'm just going to give you a demonstration now quickly. I just need to get a program loaded of how we do it. I'm just going to show one example. If I can get my computer to work. Just remind me to share my screen, because I'm very good at starting the process and then not share it. So I can see what I'm doing, but you can't. Okay, so I'm just waiting for I'm waiting for a program to load.
Are you using PLS SEM?
No, I'm going to use SPSS for the demonstration of. I'm using SPSS for the demonstration of reliability. I just need to find the file quickly. Going to the wrong place. That's right. Just give me a second here. Okay, I'm just opening the data file. And then, okay, so I just need to share my screen now. Let's go back here. Okay, so this is a program called SPSS, which is a program we use for statistical analysis. And we can use, I'm going to go through the program in more detail in a later session when we get to analysis. But I just want to show you how we would do a Cronbach alpha. So in this data set, there's a model called TPAC. It's a technology, it's an educational based model where we have the idea is that a person can have technical knowledge, they can have conceptual knowledge, and they can have pedagogical knowledge. So you've got the T, C, and P are for technical, conceptual, and pedagogical knowledge. And that that influences how a person uses technology in the classroom. So obviously, if they've got higher technological knowledge, they might be more likely to use technology. So that's what the model does. So the technical component of the technical knowledge component is made up of 5 statements. I have technical skills. I can learn technology easily. I know how to solve my own technical problems, and so on. So those 5 statements are kind of argued to make up this idea of technical knowledge. So when we're using the scale, we want to see whether so theoretically, if a person answers those questions, if they're high in terms of, if they've got high strength in terms of technical knowledge, they would strongly agree with these statements. If they're low on technical knowledge, they would disagree with those statements. So that's how the reliability works in terms of checking the reliability of the statements. So to get a Cronbach alpha result, which tests the reliability of these statements, we go to Analyze Scale. And I don't know if you can see it, you can see it on the screen. And then we go to Reliability Analysis. And then I'm going to find the TK items, which are these ones here, I think. I think those are all the TKs. Just stretch this out a bit. I don't know if that, I think there are 5. Okay, so we put the items in there. And you'll see there's a statistics thing. I'm not going to worry about the statistics here because I don't really need to use them. I'm more concerned about the model that we're going to use, and we're going to use a Cronbach alpha. So I get the Cronbach alpha from this model option here, and then I click OK, and that's going to give me a result which is 0.801. So the Cronbach alpha ranges from 0 to 1. And if you get a Cronbach, the higher the Cronbach alpha, the more consistency, the higher the consistency is of the answers in the responses to the questions. So we normally accept a Cronbach alpha of 0.8 or higher for good consistency. We can also work with Cronbach alphas lower than 0.8, but so 0.7 would also be considered acceptable. But 0.8 is the sort of better option. And there are some statisticians who would say it should be 0.9 or higher. For example, they want a stricter level of consistency. But for this, because we're working in this context, we're working in the education environment. We don't necessarily need very, very high levels of consistency to argue that the scale is working. So we would work with this particular value of 0.8. So this is an example of how we would get a statistic which tells us that we've got reliable information in terms of internal consistency. Okay, so that's how we would run the analysis for the internal consistency. The statistics we would use for the I'm just going to go back here. I'm not going to demonstrate those. Just to go back here, just of time constraints. If we were to measure repeatability, we can use a correlation. So we correlate the variable at the first time and the variable at the second time. And obviously, the stronger the correlation, the more likely there is to be repeatability in the measurement. And consistency of rating scores, we use something called a kappa score, or we can use, there's other measures we can use there as well. And there is a paper that I've shared with you by Halgren, where the paper's focusing on measures of rate of reliability, essentially. So the entire paper focuses on different types of rate of reliability that we can measure, different types of statistics that we use to measure rate of reliability, depending on depending on what value is being rated. Is it a number? Is it a category? Depending on how many raters there are they the same raters, different raters, and so on. So you can get quite complex kind of scenarios for the rating of scores. Okay. So that's, yeah, so there's lots of statistics we can use for measuring reliability, but you do need enough data to be able to do that. So you need a sort of reasonable sample size in order to do that. Okay, I'm not going to demonstrate those. Okay, then we move on to validity. So we've got, and I'm borrowing from a person called Robert Michael for the next few slides. So because he just said it much better than I could say it. So internal validity, so as I mentioned, with validity, it's quite important to understand that there's different types of validity. So there isn't just one definition of validity. There's different forms of validity. So internal validity refers to our ability to claim a relationship exists between independent and dependent variables. So that's related to the relationship between the variables that we're measuring. And then external validity relates to our ability to claim that the results that we've got for our study are applicable to other contexts or groups. So that's kind of linking back to the sample and the population and to the environment that we're doing our research in. And then a controlled or experimental design allows us to control for threats to internal and external validity because we can control the environment. If we're doing research in the open space, we can't control the variables which are coming around us. So if you think about doing if we do an experiment in the laboratory, it's not going to rain on our work. Whereas if you're doing it in the open air, it could potentially rain and affect the results that you get because it suddenly starts raining, just as a simple example of that. Okay, so threats to, I'm not going to go through all of these, but just read through the slides. So when we have, when we think about internal validity, which is the relationship between the variables that we want to measure for our study, there's certain threats that affect our internal validity. So one would be history, and that's a time-related factor. So if you're doing an experiment, for example, did some unanticipated event occur during the experiment, which might have affected the dependent variable. So we don't know, so that would mean that we don't know whether the dependent variable changed because of the experiment that we were doing or because some event occurred during the experiment. So just one example would be that load shedding, if load shedding occurs while the experiment's taking place, it might be the load shedding that explains the lower use of electricity rather than some change in behavior of the electricity user, for example. A one-group design, which is vulnerable to history, because then you can't, if you're using a single group design, which is never really a good design for any kind of research, that would the question would be, is the effect due to the treatment or due to some historical event occurring during the treatment? And that's a solution to that would be to use a two-group experimental control design. And then if this historical event occurs during the experiment, it would occur for both groups. So any difference would not be due to the this event occurring during the experiment. It would be due to a difference in the groups. So I think when we were talking about experimental design, I mentioned that the one group design is not a good design, and it's always if you can design a two-group design where you've got an experiment and a control. That's always a better design to use. Okay, maturation is another threat to internal validity. That's where there's a change in the dependent variable, just because due to maturation over time. So everything changes over time, and then that change might be due to the time rather than due to intervention. So, for example, a performance of learners might decline over time because of fatigue. And that's why, so if you think about us as individuals, when you're working as the year progresses, and we get tighter towards the end of the year, then we might have more mistakes. So we're not making more mistakes because of an intervention. We're making more mistakes because the year has got, the year is just getting more intense as time goes on. Again, the one group design is vulnerable to maturation. And a solution again there would be to use a two-group design, where both groups are having the same experience in terms of any kind of maturation. So both groups are going through time at the same pace. So if you see a difference, the difference would be due to any difference that's occurring due to maturation would be occurring in both groups. So if there's a bigger difference, then it's presumably due to the treatment. Okay. Other threats to internal validity could be statistical regression. That's where extreme cases regress to the mean. So there's a natural kind of phenomenon in measurement, or in sort of context that we measure things, is that sometimes extreme cases will move towards the mean, the average value. There's also selection. This links into the sampling issue. Was selection random or voluntary? A voluntary selection wouldn't be a problem for a single group design, but it might be a problem for a group design, for example. There's experimental mortality where participants drop out. So if you're doing a research project over a period of time, you might lose sample. Either people drop out or you might lose things. If you're doing research on plants, some of your plants might die, for example, and so you're losing cases. And then testing, the pretest if you're doing a pretest with people, for example, you might sensitize them in an unanticipated way, and their performance in the post-test might be due to the pretest. So that could be a scenario where you give a person a questionnaire to answer, and then a week later you give them the same questionnaire, but because they've had some interaction with the questions, they might answer them differently the second time round, because they've seen the questionnaire before already. So that could also affect the results that you get. But sometimes you can't really avoid you have to do the research, and you have to practice the thing, but that's just the way it works. Okay. Yeah, and then these are some other threats to internal validity. Instrumentation, that's where your instrumentation is not working properly. If you're using an instrument to collect data, you might have calibrated it incorrectly, so you're getting the wrong readings. There could be design contamination. There could be compensatory rivalry and resentful demoralization. That's where, if you've got a control in an experimental group, the groups, because the one group is aware that the other group is getting a treatment and you're not getting a treatment, you might resent that. You might be upset about that, and that might affect how you respond to the experiment. So these are different. Those are more psychological effects. Yeah, and then external validity that relates to the population validity. There's two forms here. One is population validity, which is how representative is the sample of the population, and then there's ecological validity, which relates to the setting in which your research takes place and how appropriate is it to generalize from that setting to other settings. So, for example, if you do your research in South Africa, do your findings, can they be applied and replicated in another context, say in the UK, for example? It might be that they're not really appropriate. The environments are so different that it wouldn't really be, you wouldn't get the same result if you were to do your research in a different environment. Okay. Yeah, so and threats to external validity include interaction effective testing. So that would be where, yeah, so there might be interactions between the variables which produce effects which may be mistaken for the effect of the treatment variable. So in statistics, we talk about collinearity, where there's an interaction between independent variables, and that affects how they relate to the dependent variable. So that would be an example of interaction effective testing. There's also interaction effects of selection bias as an experimental treatment, and that's how. So yeah, depending on who you've selected to be part of the study, they might respond differently to treatment and control groups. So that could be a sort of effect that happens there. Yeah, there could be reactive effects of experimental arrangements. So the effects that you see in a experimental setting might not generalize to a natural setting, because the experimental setting is very much controlled. And then there might be multiple treatment interference. So if multiple treatments are given to the same subjects, it's difficult to control for the effects of prior treatment. So that's just saying that a good design would be to kind of deal with one treatment at a time and not have too many things going on. But sometimes if you're dealing with patients with complex health problems, you might have to apply multiple treatments, for example, and then it might be difficult to identify which treatment is actually causing which effect. And this is just a link to, I must check that this is still active, but a link to threats to validity of research design. So again, you can use these resources for your assignment too. Okay. This is just also making the point that there's different types of validity. So I'm not going to be too much longer. I know we over time a bit because I wanted to finish at 12. So I'm just going to keep going for a few more minutes and then we'll stop. So face validity this is from a book by Oppenheim on designing measurement instruments. So face validity is asking the question, do your questions represent what you want to measure? So if you're talking about technical knowledge, do your questions measure this concept of technical knowledge? Content validity refers to ask the question, are the questions that you are asking a well-balanced sample of the domain content? So when we measure constructs, we usually have to measure them using more than one question, particularly latent constructs, which we'll talk about in more detail in the next contact session. But so we use a set of items. So are those items a good balance for measuring that domain, that construct that we're measuring? There's also factor convergent and divergent validity. Those are other forms of validity. Then we've also got concurrent validity, which is we can measure that using, so that means that you might have two kind of scales that measure self-esteem. So if we measure both those scales, we can then, if you've got data for both those scales, we can then correlate them, and then we know that our measurement is working because they should correlate with each other. If they don't correlate, then we know we've got a problem with concurrent validity. There's something wrong with our measurement. Then we've got construct validity, which is where if we know that self-esteem relates to confidence, then we can measure those two constructs and see if they correlate. If we know from the previous literature that there's a good correlation between confidence and self-esteem, then we can measure those two constructs and then we can test the relationship between them. And if there is a relationship, we know that our measurement is good. And there's also predictive validity. So if we know that one construct predicts another construct, the outcome, so let's say we know that certain kinds of a patient with certain kinds of characteristics leads to them being admitted to hospital, and we know there's a relationship there, we can test that, we can measure those variables and then test that relationship. And if we get that prediction that we're expecting, then we can say we have predictive validity. So again, that would also be based on prior knowledge. We'd need to have some kind of prior knowledge to be able to use that kind of validity. Okay, and then I'm just going to quickly, can I do a quick demonstration, or shall I leave it till the next session? Do you want a quick demonstration? Let me leave it till the next session, okay, because it's after 12 and I've noticed one person's dropped out. Is it Theodora's dropped out again? Okay. Okay, so I'll do this demonstration when we do you don't need this for the activity that you're doing. I'll do the demonstration when we do the statistics in one of the later sessions to show you how we do a confirmatory factor analysis. So when we do a confirmatory factor analysis, what we do is we start with a model that we want to test, and then we get data, and then we apply the data to that model, and then the confirmatory factor analysis tells us how well the data fits the model. And then if it fits it well, then we know that we've got a model that's appropriate model. And I'll do a demonstration of this when we do the statistics. We'd normally do this we'd do this as part of our process of validating the information. But let's do it in a stat session rather than here, okay? Because it's been otherwise I'm going to overload you. But it's just to make the point that we can do it though. Okay. All right. Are there any questions?
No.
No. Okay. Teboho, any question from you?
Okay. No question from my side, Doc.
Mafundo, okay, no, that's fine. Okay, all right, good, thank you. I'm going to end the session then. Sorry, it's a bit cut off, but so we'll carry on with so in the next session, I'm going to talk about. I was hoping to do it today, but I'm running behind a bit. So in the next session, we're going to do designing data collection instruments, and then we're going to move on to analysis of data and reporting results. So we're kind of moving on to the collecting data analysis. So how do we guide students in terms of those components of the research process? Yeah, but just what to take from this session is that we can, if you have data, there are ways we can measure reliability and validity. But you need to make sure, ideally, the design should be good in the beginning in order to be able to get good results for the reliability and validity. So, but just the key thing is to remember that we can measure some of these constructs. So in a quantitative way, such that when the student is writing up their results, they can demonstrate that they've got reliability and validity and so on. Okay. All right, using the statistics. Good, okay. Any questions? No, I'm going to stop recording. Okay. All right, so I'll see you.